Alright, so in this video today we are going to balance this equation. So what I'm going to do is just kind of walk through the steps that I would follow to solve this problem. It is just one of many ways to do it. I'm going to do a couple reminders of kind of why we balance and what that means, but this video is mostly just one example of a type of a way to solve this problem. So one of the things that you'll always see me do is put kind of this line at the arrow, because we know that the left side of the arrow, before the arrow, is before the reaction happens, and the right side is after. So I'm going to start off by just kind of making sure that I have separated this equation in the right place. One of the big mistakes I see is people just kind of, the pluses and the arrows mixed together. People forget what they're looking for. We need to make sure that the arrow is the line where we draw our before and after. So that's the first step, pretty easy. Our second step is to figure out which elements we have. So on the left side here, we have H2 and Cl2. A lot of time people will want to call that an I. If you see C and something like that together, it's probably chlorine. It's probably Cl, but I'll try to use fonts that make it clear. So we have an H. That is one of our elements. It is hydrogen. We should probably know that already. And then we do have, like I said, chlorine. We have Cl. One mistake people will make is they'll want to put C and I and make it carbon and iodine. That would be wrong. It is a lowercase l, so this is all one element. So it's chlorine Cl. This is a lowercase cursive l, so that we know it's not an I. And on the left, we only have one molecule, but we have the same two elements. We have an H, we have a Cl. And the very, very first thing I do, and I'm going to do this all in one color, and then we'll switch to a different color once we start making changes. That's our second step. So our first step was just drawing this line, splitting up before and after. Our second step, well, that is our first step. Our second step is just identifying each of the elements, recognizing there's a hydrogen and a chlorine on each side. If there's something on the left, if there's like an oxygen over here that wasn't on the left-hand side, that would be a sign of trouble. We're never going to see that. So our third step now is to just count how many of each element there are on both sides. So I picked just a slightly different color here. So let's start on the left. H2. That means we have 2 hydrogen. In a different video, I can draw out what each of these molecules will look like, but today we're just solving the problem. And we have 2 chlorines. There's a little 2 next to our Cl, so we also have 2 chlorines. On the right-hand side, we have 1 of each. There are no numbers here. There's no coefficient. There are no subscripts. There's nothing in there. So since there are no numbers, we know we have 1 of each. So we only have 1 hydrogen and 1 chlorine. And that's our third step. That's everything. We've counted up how many of each element we have on both sides. And now we can tell that it is not balanced. We want a balanced equation. These two things got to be equal. The hydrogen on the left and the right has to be equal. The chlorine on the left and the right has to be equal. Because it's the same hydrogen, right? And it's the same chlorine. And again, we'll talk about that more in another video. This is just one way to solve the problem. But these two things have to be equal because they're the same. So this H2 has 2 hydrogen. What we have right now is one of them is disappearing. And that doesn't make sense. So in order to make this balanced, this is one of the easiest ones we'll ever do. We'll do a couple harder problems after this, but this is just the basic first way to do it. We have a 2 on the left, we have a 1 on the right. If we put a 2 here for this coefficient, I guess this would be our step 4, is adding our coefficients. Adding coefficients. So if we put a 2 here, we are now saying, just like if you have a coefficient in math, this 2 means there's 2 of everything here. We don't really draw the parentheses in chemistry, but they can help kids connect. They help us connect back to what we learned in math. So now that there's a 2 here, and we know to multiply everything by 2, we have 2 hydrogen, we have 2 chlorine, and that almost seems too easy because now everything is balanced. It's equal. There's 2 hydrogen on the left, 2 hydrogen on the right, 2 chlorine on the left, 2 chlorine on the right. That's it. That's all you had to do for this one. It is that easy. It is balanced. If we want to fill in, we still have these blank lines. Students really like to fill in these blank lines. They really like to fill them in order from left to right, but we're not doing that. But if you really want it, you can just leave it like this. This is done. This is 100% correct. This is finished. This is 100%. You can add a 1 on these lines too, if you want to, just to have something there. Just like in math too, right? If we had 1x, that 1 doesn't, it's still just x. The 1 doesn't change anything. But if you just want to fill in the lines, you can throw down a 1. So that is it. We will do a slightly trickier one next time, but that is how you balance an equation in the simplest terms.